Hey everybody, Mr. Piercy here. We're going to be talking about deductive reasoning in today's lesson. Deductive reasoning is a type of reasoning that relies on statements to form a chain of thinking, and the chain can be long, it could be short, it doesn't need to be very complicated, but what we're doing is relying on some statements that will allow us to draw a conclusion. Just think of a time when you've had to convince somebody, probably a parent or maybe an older brother or sister, to do something. You know, can I spend the night at so-and-so's house? Can I go to this concert? Can I get this new thing? Whatever it is. And you had to try to justify it in some way. Well, that's what we're going to be getting ready to do. So here in deductive reasoning, to begin with, there's an exercise that I want you to try and be able to work through. We have a situation where you're buying 3 pairs of pants. Make sure you read what it's asking you to do and find the values, find the averages of these 4 combinations and see what you come up with as values. And based on your answers, draw a conclusion about which combinations of jeans you could buy. So go ahead and pause the video when you're ready, answer these questions, and when you're done, push play again. Okay, so I'm guessing that we're all ready to go, and let's see how we did. Now, when I ran this exercise in class, I was very excited to see the numbers that they were doing because I told them I am immediately going to start opening up a store and have them all come be customers because they're going to give me a whole lot of money. So let's see how you guys did. Find the average cost of jeans A, B, and C, and we would have spent about $27. Because the coupon says that the third pair of equal or lesser value is free in the combination of jeans A, B, and C, A is the cheapest one. So you don't have to pay for it. So it's 0, but you're still paying an average of all 3 jeans, so you have to include it in the average itself. So that's how we got $27. Well, let's look at ABD. Well, ABD gives us a slightly higher average of just under $30. Looking at ACD, that gives us an average just even a little bit more of $30.33. And finally, BCD gives us an average of $30.33 again. Now the question does ask us, what is the average amount you'll spend if you want to spend as little as possible? Well, if you want to spend as little as possible, you really want to go with this one right here. Now, we're making that decision based on the information that's provided. Even though we are looking at numbers, we're not looking at values to try and distinguish a pattern that's changing. What we're doing is we're looking at information, and based on the information, we're drawing a conclusion, a specific idea that we're trying to adhere to. Now, in my conclusion, I did say a little bit different because in my conclusion, I did say, well, A, B, and C does give you the best average, but you know, depending on the quality of the jeans, I may very well consider going with B, C, and D instead, simply because I don't know, maybe if they're more expensive, maybe the quality is better, maybe they fit better, maybe they're more comfortable. I don't know. So I may very well just fork over the extra $4 almost and get the B, C, and D jeans, but that's me. So we're going to now be taking a look at something known as in geometry as the law of detachment. Now, here it's kind of based on the idea of we're taking a conditional statement and another statement that's not really a conditional statement, and we're using the parts of the conditional statement to determine can we make a conclusion or not. Looking in the picture here, the property of the law of detachment is saying we're looking at the hypothesis of the conditional statement, and then in the example it says, well, we're going to kind of look to see, well, is the hypothesis of the conditional statement, and this should really be talking about the subject of the other statement, and if it is, then that means we can draw a conclusion. So this is what I want you guys to think about. That's why I'm adding these text boxes to your diagrams here. It says, okay, so we have a conditional statement. We want to be able to identify the hypothesis and conclusion. Well, here, let's do the hypothesis yellow, and let's do the hypothesis, or I'm sorry, the conclusion here. Let's do that blue color, and we're going to say, so the hypothesis is a student gets an A for a final exam, and the conclusion is that the student will pass the course. Well, what we want to know is, does the statement, the one that's not a conditional statement, but just a statement, is the subject of that statement the same as the hypothesis of the conditional? And when we look at it here, what we're really talking about in the hypothesis, we're talking about a grade, an A on a final exam. And Felicia is talking about getting an A on her final exam. So they are, in fact, talking about the same thing. So they go together. So I'll color code them the same. Because they go together, that will allow me to draw a conclusion between the statement that Felicia says and the conclusion of the conditional statement. And I can say, well, because Felicia got an A on her final exam, it must mean that she passed her history course. So what we're going to look at next is a couple of examples that I want you guys to try on your own. Same idea. There's two more examples. I want you to go ahead and pause the video and determine, can we draw a conclusion off of the two given situations? And when you're done, come back. So go ahead and pause the video now, work out the next two statements, see if we can get something with the law of detachment. And when you're done, come back. Now, let's take a look at the given statement. Now, I'm not going to identify the hypothesis and the conclusion in both of these. I'm really going to just look at the hypothesis, because that's really all I'm looking at in when I'm thinking about the law of detachment. I want to know, does that statement, does the hypothesis coincide? Does it match with what the statement is saying? Well, our hypothesis is saying that a ray divides an angle into two congruent angles. And what we're seeing here is that we have a ray dividing an angle into two congruent angles. So even though they don't, one is using more English prose to say it, and another one is using more geometry symbols to say it, they're still talking about the same thing. They're still saying a ray dividing an angle into two congruent angles. So in this case, I can draw the conclusion that ray RS must be an angle bisector. I'm going to take what we're talking about in the statement here. Oops, didn't mean to do that. Thought I was on my pen. I'm going to take what we're saying in our statement here, and we're going to combine it with our conclusion. And that's what we get with our that example. So the last one here, if two angles are adjacent, then they share a common vertex. The hypothesis here, angles are adjacent. So looking at the statement here, these guys are talking about, let's see, let's come here. Here they're talking about a common vertex. And the common vertex isn't here, it's here in the conclusion. Because the subject of the statement goes with the conclusion of the conditional, we are not going to be able to draw a conclusion using the law of detachment. So that's kind of what we're going to be looking at here. The hypothesis and the subject don't match, so we can't draw a conclusion using the law of detachment. Now, the last one that we're going to talk about here is the law of syllogism. The law of syllogism, I like to think of it as a way of kind of producing a shortcut from one point to another point. Now the table that you're seeing here, is the symbolic table that we're seeing, is what we're looking at is we're saying, okay, I have this conclusion of a conditional statement becoming the hypothesis of a second conditional statement. So when these two things meet, when the conclusion here and the hypothesis here, when they match, essentially what we're going to do is they cancel each other out, which allows me to take this hypothesis and go directly to this conclusion, which is essentially what you're seeing down here at the bottom. And in the example, we can see it. The first statement says, if it's July, then you are on summer vacation. So we see in blue the you are on summer vacation matching with the hypothesis of the second statement. So because this one and this one match, essentially what we do is we can say, okay, well, if they match, we no longer need them anymore. And I can take this hypothesis and this conclusion, and we form this new conditional statement. So let's take a look at our example. Now, one of the things stylistically that we can tell is different between the law of syllogism and the law of detachment is the law of syllogism is using only conditional statements, whereas the law of detachment used statements that were not conditional, meaning they didn't follow the if-then format. Now, looking here, I want to see how do the parts match up. So I'm going to just start looking at things. Here I have a hypothesis that says a figure is a square. Here I have a conclusion that says a figure is a rectangle. Going to the second conditional statement, I see that the hypothesis here is the same as the conclusion of the first statement. And then we have the final conclusion here that says a figure has four sides. Because the hypothesis here matches the conclusion here, essentially what happens is we cancel those out, and I take what's left over. I take the hypothesis of the first statement and the conclusion of the second statement, and then I draw a new conclusion, and I write it in an if-then form that says if a figure is a square, then the figure has four sides. So that's how the law of syllogism works. And what I'd like you to do is at this time, there's two more examples that follow this in your notes. Pause the video, attempt the next two examples, and when you're done, come back and push play. So I'm going to presume, again, everything that you're doing what I'm asking you to do. So let's see what we have here. Looking at these two sentences, these two conditional statements, I want to know, because really what I'm looking for, if I'm practicing the law of syllogism, I want to know, does this conclusion match this hypothesis? And in this case, one conclusion is talking about something being flexible, and the second one is talking about in its hypothesis that they do ballet. Now in this case, the conclusion of the first statement does not match the hypothesis of the second statement. Therefore, we cannot make a conclusion using the law of syllogism. And in our second example that you practiced on your own, here again I'm going to look at the conclusion of the first statement that says something is divisible by 10, then compare it to the hypothesis of the second statement, which also says a number is divisible by 10. So therefore they are talking about the same thing, which allows me to make the conclusion, if a number ends in 0, then it also is divisible by 5. Now as we're going over these things, again, if you have questions about what they mean, why do they behave the way that they do, again, just make sure that you email me or leave a comment for me in the Google Classroom section, and I'll be happy to help you with it. So finally, this is going to be the last portion that we talk about. the last kind of exercise that we're going to be doing is going to take both of the laws that we talked about, law of syllogism and the law of detachment, and it's going to put them all together at the same time. Now, in the given information, we have a problem that says if you live in Accra, then you live in Ghana. And if you live in Ghana, then you live in Africa. So finally, we have a statement that says Aisa lives in Africa. Now, I want you to understand the reason why I'm trying to put these things together the way I am. This part, this is the only thing that you'd see on a homework assignment, on a quiz, something like that. It's just giving you the information and saying, can you do something with it? And if you can, what would you wind up with? The information underneath, the questions, those are the things I'm making you try to think about to see how can we do this. So let's read through it. So the first, does the conclusion of the first statement match the hypothesis of the second? Well, let's see, does it? So the conclusion of the first statement says, you live in Ghana. The hypothesis of the second statement says, you live in Ghana. Those are pretty identical to me. So here, where it asks me the question, we're answering this question here. Yes, they do. So because they do, we can write a statement based on that. And I think I need to erase my answer here so we can actually see it. So since they do match, we can write a new conditional statement that says, if you live in Accra, then you live in Africa. Now the second part says, well, we can take the conditional statement that we have, like our new conditional statement, and let me go ahead and illustrate that here. It's talking about the new conditional statement, which is that one right there. And we can use the law of detachment, maybe, to draw a conclusion. So again, using the law of detachment, really all I'm going to be looking at is the hypothesis of the conditional statement and the subject of the non-conditional statement. Well, the hypothesis says, well, you live in Africa. Here, the subject of the statement is also talking about somebody living in Africa. So because those two match, we can now make a connection and draw a conclusion based on the law of detachment that says Aisa must live in Africa. So essentially what I'm doing now is I'm going to take, let me get another color here. I'm going to take the fact that Aisa, and I'm going to combine it with the conclusion here, living in Africa. And that's how I draw that's how I write my conclusion using the law of detachment. Now our final example, again, what I want you guys to do, ladies and gentlemen, is go ahead and pause the video at this time and see, can you make a statement? Excuse me, I have a chest cough. I'm trying not to cough in your ear here. But can we use the law of syllogism and the law of detachment in this situation? And I've taken away the thinking questions. I've taken away the structure. So if you need to, refer back to the other example and tell me, can you draw a conclusion here? So pause the video now, and when you're done, come back and check your answer. All right. So let's see what we have here. Looking at the conditional statements that we were given, I'm going to see, does the hypothesis here, I'm sorry, the conclusion of the first statement, does it match the hypothesis of the first one? And they do. The conclusion of the first sentence is talking about the length of the Amazon, something being longer than the Amazon, and the hypothesis of the second one is saying the same thing. Well, that allows me to make a statement between, I don't want to do highlighter here. That will allow me to make a conditional statement using the hypothesis here and the conclusion here. Now, because those two match, that gives me my final statement here. If a river is more than 4,000 miles long, then it's the longest river in the world. So there's my statement using the law of syllogism And so my conclusion, using the hypothesis of my new statement, does it match with the subject of this non-conditional statement? So yes, they do. They're both talking about a river being more than 4,000 miles long. So our final conclusion says that the Nile is the longest river in the world. Now, as you've been taking the notes, again, ladies and gentlemen, any questions that you have, thoughts you want to share with me, make sure you email me, leave a comment in the Google Classroom. I'll be happy to get back with you. But until next time, guys, thanks for watching and take care.